Welcome back, everybody. This is Will Bezard here with you, doing another CAD tutorial for Rhino, running Rhino 7. But today we're going to go over how to model a bridge. And I decided that we would start with something that I do quite often at work, which is reproducing an existing bridge for repair. I like to do this especially for production style instruments because modern production guitars generally have the bridge CNC'd largely to some degree. Making a catalog of these parts is really important for efficiency doing repairs at the shop in the future. This is also advantageous for remaking a bridge for a vintage instrument because, as you can see here, I have scanned this Santa Cruz guitar bridge on its bottom side, and we can see exactly where the holes are supposed to be. And so we can factor that into our model and end up with a perfectly fitting bridge the first time that we do it. Now, the bridge that I had was considerably shorter than it should be, probably about half its original height. Whoever owned it was avoiding doing a neck reset, I think, for a very long time. So the model is probably a little strange compared to an actual Santa Cruz guitar bridge, but this was the best I could figure just looking at photos online. The bottom line is, even if it's not exactly perfect, this gets us super close, so we can do any sort of small adjustments by hand with just some sandpaper, really. So let's go ahead and get started. I am going to probably just dismantle parts of this bridge to get us started, but I thought I would show our drawing and what I might do to initiate drawing this guitar. A bridge like this, which actually ended up being asymmetrical, was a little bit more challenging than a perfectly symmetrical bridge. You'll find that handmade parts are far from being symmetrical. I don't remember what year this guitar was made, but I think it was pretty old. And so one of the issues that I ran into was, for instance, where the peaks of these scoops lined up, they were just a little weird next to the profile. They're not in exactly the same spot relative to the center. And that proved to be a little bit challenging. But for demonstration purposes, I'm just going to make us a perfectly symmetrical bridge so that we can get through the basics of modeling a bridge, which is a little bit complex. So far, if you've been following along, we've done a fretboard, a very basic one. We've also done a scalloped fretboard, specifically a compound radius, multi-scale, fully scalloped board, which is something that I had a lot of fun doing, but that's a really niche kind of thing. But I do hope if you watched it, you picked up some good little tricks to modeling stuff in Rhino. I generally, when modeling in Rhino, will simply build a frame out of wires and then drape surfaces over it. We can start with solids and cut them down, or we can extrude solids out of stuff, but I don't know. Probably mostly due to stubbornness, I still just do it this way, mainly because I feel like I have a little bit more control over the specific dimensions of things. So as we move forward, I want you to pay close attention to the command dialog. Working with a program like Rhino, I like to think of it as having a conversation. I'm simply entering things in to the command window. It's responding, asking for further input, and then I respond, giving more of that input until I get what I want. And what I've just said has reminded me of a really good trick that I've been using recently, which is accessing artificial intelligence, in this case, ChatGPT, to help me if I get stuck. ChatGPT in the last several months has accelerated my knowledge of this program more than anything else, I think. If you have a good grip on the program, you can use it to learn new commands, for instance. In this dialogue that I had with chat, you can see I was drawing something that was a particularly complex shape, and I planned to 3D print it, and so it absolutely had to be a closed poly surface. Something like a bridge is pretty easy to make that happen with. If you can make surfaces intersect one another, you can trim them with one another, and then that makes their edges, perfectly joined, and then you can close it. But I was struggling with it. I learned this command here, which is called cap, after attempting to use show edges to find where my surfaces were not meeting and preventing it from closing. With cap, I simply selected the whole model that I'd drawn, entered cap, it closed it, and it was done. It was very simple. So don't underestimate how useful artificial intelligence can be for teaching yourself this kind of thing. All right, we're done with the detour. So this picture here, I don't know if the first thing that I would do is make sure that it's square. Okay, so I did adjust it. So it came into the program like this, which is very small, as you probably just saw, but it really matters. I need to make sure that this, when I start drawing this, that some reference edge, usually I would use the front of the bridge, is parallel to or perpendicular to the grid lines within the program. As far as the grid that you can see here, I generally don't use that. I should probably start turning it off. I just use the command here, ortho, which is going to make lines snap to perpendicular of that point. So I'll zoom way in here after selecting my picture or scan. I'll zoom way in, grab it on the front, come up here, and I can see, ooh, that is not parallel to what the program's going to want to snap to. So to be as accurate as I can, I'll grab it here and then just place it like so. From here, we can start laying out our lines, and I'm simply just going to trace the bridge itself. Using the line command, as you will probably see if you're watching my command window. Feel free to slow it down or rewind it if you miss anything at all. Now, I've got my straight lines. I need to make a curve to follow this. So sometimes I'll do a command called curve through point, which requires me to place numerous points across, this back really fun curvy profile of the Santa Cruz guitar bridge. But I'm not going to do that. I'm just going to enter curve and freeform or freehand, perhaps, a curve. Now, I mentioned ortho. You can see that ortho is going to make me want to, either be parallel or perpendicular to where I've started from, and that's because ortho is on. So as I'm drawing this curve, I'm going to hold shift to temporarily turn off ortho and allow me to, freeform and do a bunch of jazz. And I'm pretty much, just going to put as many points on this curve as I think I need to, so that it is relatively accurate, and it's okay if it's not perfect. We just need to rush through this and get it done. Okay, now I have this curve, but, well, it's a lot of points. We don't really want a bunch of points. The more points we have in a curve, generally when we extrude or make surfaces from it, it's going to add what Rhino calls hash lines or intersection lines, and it's going to make the surface really busy. It's going to give it a lot of redundant and extra information that we don't need. That can make rendering it an issue, because essentially, like I said, it's redundant information. It's loading too much stuff to make something that's generally pretty simple. But later, when you go to machine something, if it has all of this stuff, the Rhino Cam sees that, and this can affect how smooth your machining path ends up being quite a bit. So what I'm going to do is use the rebuild command and reduce the number of points. We want a 3-degree curve, and as you can see, this new one is going to be pretty far off, but 6 points might be appropriate. We're just going to try it out and see how close we can get, and that's not going to cut it. So we will rebuild once more. Maybe we'll add 2 more points, because I feel like the way that this curve was moving, I felt like we were coming inside of this profile. That's kind of a unique thing of the Santa Cruz guitar bridges, is that they stay really straight or even come out a little bit and they dive a little bit deeper in than other acoustic guitar bridges and then swoop around. So we want to maintain that. I'm going to place this here as like an anchor point. This is a great place for a gumball, by the way, which is what these arrows are that I'm interacting with. I should pause for a moment to explain the brilliance of gumball. It's basically going to allow us to rotate or move something very quickly and imprecisely, perpendicularly across the axes of the program. So I love Gumball when I need to really keep something moving. It helps quite a bit. So here at this point, it can be a little bit finicky, but we're just going to keep moving around and just get really close to it. And we might find that we need to even add a point. So insert control point as the name that I want, and we're going to add one like in the middle. Okay. So now we have an additional anchor point. I can move this down, get this down here. Here we go. Okay, now we're close. Now we're really close. This probably just needs to come this way and up a tiny bit, back over. We're going to get really close. Now, as I mentioned, it's not that important that it's like perfectly accurate, right? Because we're going to cover the area of the top that's where the finish has been removed. And as long as we're over that and we're faithfully close to it, then it's fine. For instance, I mean, we can go ahead and measure this difference. I'm probably off, okay, 6/1000 of an inch, which we're going to probably sand away anyways. Bottom line is, nobody's taken a microscope to the underside of the bridge that you made. So it makes no sense to sit here and mess around with trying to nail that. Okay, this guy needs to come in. Okay, this can come out. Oh, we're close. We're close. We are very close. Okay, this is maybe going to seem slightly redundant with the next steps that I take. But just to recap, so far we drew straight lines to do that part of the profile, and then we used curve, and then rebuild, and manually moved the curves until they were matching the profile. Anyway, we are now going to make circles after measuring this. I'm using the dimension command, so that is, okay, 0.225, so I'm going to use the command circle, pick where my center is, and I don't want the radius, I want to do the diameter. So you can see, I mentioned having a conversation with Rhino, right? I've entered circle and I've begun, but it's asking for more information, right? So if I was to type in a number, it would be the radius of the circle. I could do quick math in my head and divide 0.225 by 2, but I'd rather just hit diameter, which you can either click or type the underlined letter in, press enter. I would rather use diameter because that's the actual number we're asking for. So I type in 225, hit enter, and oh wow, look at that, I got pretty close. Just eyeballing the center, but we're going to put it right on it. Okay, now I'll use copy and just up. See, if I move straight down, we're staying perfectly parallel to that first one. These holes are not perfectly aligned, okay? Which, if I was to assume that they were, this would be extremely problematic when we go to install our new bridge on this existing guitar. We would probably have to patch and re-drill the holes, which, is going to add to the time spent on the repair, and then you're going to want to charge the guy or gal extra for your time spent, but you're not going to be able to because, well, it's just not what we do. I got holes, and I got a profile. I can now hide my picture. Look at that. In terms of placement of the bridge, I measured the very end of the, outside of the wall of the saddle slot to the front edge of the bridge, and I'm sure I got that number. I'll do it on that side, and then I do it on this side, right? So I use those measurements so I can get accurate placement of the saddle slot, and then built, a nice little sausage for us to make a slot out of. I'm not filming myself, nor do I have the bridge blank or the existing bridge or my calipers. So we're just going to copy this from here and put it on our other model. And I'm going to use this corner to place it. Boom, right there. Okay, now I'm going to trim. Okay, and so just because I know that it was very annoying to draw this asymmetrical bridge, I'm just going to trim one half of the profile and then mirror it. Join those into a closed curve, and then I use the left-hand side. I'm going to measure this edge to the end of the scoop, 1.4905. Let's just do 1.49. So believe it or not, we are almost done. I just need to do a few more little steps. The first of which is to draw a line on the center. I'm drawing a line on the midpoint, which will be 3/8 of an inch tall. It's a pretty standard bridge thickness. Okay, and then I will use the circle command, and I'm going to move to this window because this window is facing this way, right? And if I want to draw a circle that's going to be, snapped to this orientation. I have to do it in this orientation. So I'm going to switch back to drawing my circle as a radius by typing R and hitting enter. And now I don't remember what the radius was, but we're just going to pretend it was a 16-inch radius. Okay, I got that, and I will extrude both of these just like we did with the fretboard in the previous step. They intersect one another. I select them both, and we trim. Okay, some makers stop at this point, which is, I think, totally cool to do. But we're not going to do that because most of the world doesn't do that. Or in this case, Santa Cruz guitar does not do this. And this poly surface is actually going to become useless in a minute. This is a little bit of a redundant process that I will do sometimes. Alternatively, what we could do is, since I know that's where the wings end, I will draw lines. Okay. And actually, we can just mirror it. I really prefer, if I can, do one half and mirror it to the other side because it's a little more efficient. And then from the top side, I'm going to use this to trim that. And then I can move this. It's kind of a fun trick. I'll select it here, and I'll go back to my top view. And if I just do very tiny little movements, you see where we can snap to that spot. Alternatively, we could draw a straight line down from this point and then simply move it, up. Right, but this is just a little bit cooler, I think. Bingo. So now I can mirror this once more, trim once again, and then we can extrude our curve this way, extrude this one, and then do that. Okay, so now I got the top of my ridge, and we're good. I'm pretty sure this is 100,000ths of an inch on the wings. Oh, it was 110. Interesting. So I'm going to copy this upwards, 0.110. Okay, and we're getting pretty close. I'll draw a line straight up from here. I will move this to here and then copy it onto the top surface. You're going to see why in a second. I head back to my right hand orientation. I make a circle. In this case, the radius is probably an inch. I think we use a 2-inch spindle sander oftentimes to do this kind of thing. I'm going to now lay it down on this guy, which is what I want the bottom of the wings to be. Okay, you can see that it's also intersecting this top one. Then I can grab it here and move it over, kind of pretend that it's a disc sander or removing that material. And then we can select these two and get that, and then trim this with that, get rid of that, and then boom, we got it. So we will join this. I will move it here. Okay, and then I'm going to copy this somewhere out here. And the reason for putting it so far out is so that we can absolutely trim that with the profile. I'll draw a new line here because I'm going to use sweep 2 in a particular order of operations. What I want to do is select these as my rails, so the outer 2 straight lines, and then our scoops as the sweep shapes. When I do that, I get a single nice crisp surface that, as you can see, is one surface. If I try to explode it, I can't. It's a single surface, right? So now I'm going to extrude this once more and trim that, and then I can mirror this surface because I know it's symmetrical. Okay, I'll grab this surface, nope, excuse me, program, and then I can trim the top side. And would you look at that? We're pretty much there, right? And at this point, we can join this all together and make a closed poly surface. Isn't that cool? So the next thing from here would be to select and project our saddle slot onto the top. Okay, and then I'm going to go into wireframe here. I'll draw a straight line down on the center, whatever I want the depth to be. And let's just say for this time, we want it to be 1/4 of an inch. Okay. On the middle point, I'm going to grab my 2D shape, move it to the bottom. And now I can sweep 2, which is a great command. This rail, that's a rail. This is an intersecting curve. Boom. We get a surface. Okay. Which we can now delete the other stuff, and we've got this nice little, I think like 100 thou width slot. Oh, actually, that's kind of gross. So we're going to delete that. We're not going to do sweep 2 here. We're going to extrude curve straight up, and then we'll use our surface to trim that, and that's better. I generally like to try to extrude when I can, but there's numerous times where network surface or sweep 2 is just the way to build a curve. As I was saying, model a bridge, including the string slots, the chamfer and the top of the holes, all the carves. I've even seen people model a intonated saddle and carve it on the CNC machine. I mean, there is no limit or boundaries to what you can do. If a shape exists, you can fixture, you can model, program, and fixture anything. The only limit is you and your imagination. I'll extrude curve once again. Okay. Now we have trimmed. I will select these and trim. I think at some point I changed my settings so that extrusion makes a poly surface, which is a little irritating. I'm going to have to take a look at that and change it. I'm deleting those bottoms. And now trimming. There we go. That's the thing. So as for the round over in the backside of the bridge, just about everybody does this a little bit differently. What I noticed about the Santa Cruz Bridge and the photos that I could find was that it was a little further and seemed to, really reach upward and do some weird stuff. And so I ended up just kind of, you can see this is a little wrinkly. So we just had to sand that real quick with like some 220 to get it normal looking. But, that was clearly something that was designed not thinking about how it would be drawn in Rhino, which is not a problem. It's just the way it is. So we're going to do a straight line. I don't know. Let's just say we put it here. Okay. And then let's say we want our curved area to end at the 100th thou line that our wings do as well. Okay. We're going to make a curve. This is just a perfect 90-degree curve. So we can see right here. That's a nice shape. I like it. It's an even subdivision of those two areas. And then what I like to do is then copy this to where it intersects the wings. This is going to make it a little bit easy to model this. And I'll grab these 2 points. Rhino doesn't want to snap to it because we can't see it. Going to wireframe is going to help. What I'm going to do now is trim that so that I can snap to that intersection point. Now, this is a technique I use a lot. You've probably seen me do it a couple of times. Okay, we've trimmed that accordingly. So, in short, this technique I use is kind of something I just intuitively picked up after trying to model different stuff, but using new lines that are just kind of throwaway lines as a way to trim things to a termination point can help a lot when wanting to do this kind of thing. Okay, I just grab these 2. I'm going to pull them down. I grab this one and put it there. This one and put it there. Okay, so now that is still a continuation of that shape. Go ahead and mirror there. And now I can use network surface, bouncing between these 5 lines. Boom, then we got that. But it's not complete because there's this incompleted area here, as you can see. What I like to do, because I feel like it's just easy, is extend surface and just shoot it out a little bit. Now this works to a point, but as you can see, the curve really starts to get weird if you go too far. So you want to go just a little bit, a little tiny bit. We're going to try network surface in a different way, but part of what's making this weird is that this curve on top is straight, but radiused across the z-axis, and this line is not moving across the z-axis, but is moving a lot across the x and y. And so when we go to extend surface, it can really make this weird. And what I want it to do ultimately is clear the wings, but yeah, it's not going to happen. You know what? I know it's going to help. We are going to pull this line downward a little bit so that we're kind of matching this shape. And I think that's more attractive anyways. So now we'll try our network surface. Oh, after we move this. This is probably the most challenging part of doing this technique. I've, in the past, have spent hours just going around in circles trying to get something drawn and getting nowhere. So if we extend the surface now, yes, I'm going to use just the regular extend command and extend these outward to build a proper frame. Gonna project it onto the side. Ooh, not that hole. All right, this will work. Sometimes we have to treat one of these surfaces that we're making as its own thing. Okay, I'm gonna extend these to the ends of our new lines. What this is gonna do is make it so that this new thing that we're building is going to clear these troublesome shapes that we have. And then we will be able to trim and make our final surface out of it. This has to be probably the trickiest area of modeling bridges. As you can see, I just struggled with it. And I've drawn, I don't know how many bridges in my life so far. Okay, now we've got something overshooting all of this, which we can trim away in whatever order this thing seems to feel like it's going to do. Exploding that will help. Yep. Okay, so we've been able to trim everything but this part of the surface, which I'm just going to use my line to do so. But we don't need to be worried about that necessarily. There we go. All right, Rhino can be so picky sometimes, but now I've got a nice, pretty little round over shape that I'm happy with. And you'll see we can still select all of this and join it into one closed poly surface. So if for some reason you wanted to 3D print this, I don't know why you would, but you can. Now 3D print this bridge on a little 3D printer. Oh, one more thing I'm forgetting is getting the radius in the bottom of the bridge. It's very common that a bridge will have a radius in the bottom of it. It's the same thing as we did on the top, just in reverse. Okay, we're doing reductive rather than additive drawing here. Draw a circle using diameter. I think at Galloup we use a 63-foot radius, which is, basically flat. Oh, I typed 63 inches. That is not 63 feet. 756 inches would be what we want. Wow, look how big that circle is. All right, and we got that. So we're going to do extrude. And up here it says solid. Yes, I don't want a solid. I just want a regular little surface. Okay. Then I will explode this into our bunches of surfaces. Delete this stuff. Okay, delete the bottom. Just going to move this down, extrude it straight up. Doing a whole lot of intersection here. And I'll basically just use this to trim that gone. Now we have a radiused surface here. And if I want to, I can just use the edges of that surface to extrude a new surface. Sometimes, even though it is genuinely touching another surface, it will not trim. So we got to use that to trim. And we're going to get rid of our lines. We don't need any of these curves, really, because we could later extract them from this model. Select it, join it. Oh, open poly surface. Okay, there's probably something going on in here. But like I mentioned earlier, we learned that cap command. Let's see what cap does. And we created 6 caps, closing it into a perfectly closed shape with that very faint radius in the center of it. We're just going to do cap. Let's stick with it. I'm not asking any questions. I have done this to some stuff I've printed recently and have not found an issue with using cap. It says here created 6 caps. So, I mean, there might be something next to microscopic in here that is just slightly open, but it's not a problem. Here we have a beautiful closed bridge model that's ready to be machined, slapped on a guitar. So that's about all I got for you guys today, but I look forward to you joining us soon to model some guitar, acoustic and electric guitar bodies, which I'll preface by saying is essentially all these same operations. I probably won't be teaching you anything new. It's the same commands and sequence of operations, just a different shape. And with that, I leave you. Good day. Good night.